A long straight conductor carries a current of 100 amps. At what distance from the conductor is the magnetic field caused by the current equal in magnitude to the Earth's magnetic field? The Earth's magnetic field is approximately 0.5 times 10 to the minus 4 Teslas in London. So what we're saying is, if we set up an experiment where we got a long straight, so that's a conductor there, a long straight conductor, we stick in 100 amps through it, and what we want to do is measure the magnetic field with some instrument that can measure it accurately. We want to find at what position here, in other words, what radius, is that going to be equal to exactly the same amount as the Earth's magnetic field. With a magnet that's got a very light needle would be best, because you do need a lot of current to get that magnet needle to be completely perpendicular. We can use this equation as we've got before. U naught I over 2 pi r. Everything except r is known, so we can solve for r and insert the appropriate numbers. So we know that ui, that's the constant for a vacuum, that's the permeability constant, so that's 4 pi times 10 to the minus 7 Teslas meters per amp. And then we've got the current, which is 100 amps, and then 2 pi over, and we're given the Earth's magnetic field. So the radius, if you used 100 amps, you'd need to be just under half a meter away. The R. So if you had 100 amps running through this conductor, and you was, say, I don't know, can't really show it on, it's not big enough, but say that was just under half a meter, then you would find that the needle would be well, actually the needle would be in this direction. It would be completely, any other direction, then it might not be exactly, because of the influence due to the Earth's magnetic field. So at smaller distances the field becomes stronger. For example, when r equals 0.2, b equals 1 times 10 to the minus 4 Tesla, and so on. So if we decrease the radius, obviously that will become even more at right angles. Then we'll get it, the closer we get it, the more right angles it's being, because then of course the Earth's magnetic field won't have any effect compared to how strong this current is affecting this compass needle. So that's a good experiment you could actually do. That nicely shows how this equation actually works, so you can prove that equation there.